Salutations to you out there. You are welcome to my physics class. Awesome physics class. We have another question to solve today. And the question we are solving today is under the topic elasticity. Let's go solving the question on the board. We are given a spiral spring is 25 centimeter. The spiral spring balance 25 centimeter. But under elasticity, we need to always consider Hooke's law, and that is what we are given because we are told here that assuming Hooke's law is obeyed. For Hooke's law to be obeyed, we are going to have F is equal to KE, where F is the force, the K is the force constant, and the E is the extension. But we need to understand something. Our extension E is equal to L1 minus LO. L1 is the extension that you are going to have when the force is applied, when the load is applied. YLO, YLO is the initial length of the spring without the load. So if you look at this question, we are given the first one, L1. This is our L1, and we are also giving our F1. Substituting these two into the equation, we are going to have 5 is equal to K into L1 is unknown. L1 is given, we have 25 minus LO. Let's consider the second one too. We are giving the second one, we have L2, and we are giving the F2. That means we are going to have here too. We have 10 is equal to K into 30 minus LO. What we need to consider in this, I can call this one 1 and call this one 2. Let's do it like this. What we need to consider is that the force constant must always be the same, and the initial length of the spring must also be the same. So I have my 1 and I also have my 2. If you look at this equation 1 and equation 2, you will observe that equation 2 is somehow bigger than equation 1. So from here I can write divide equation 2 by 1. If I should divide equation 2 by 1, that means I'm going to have 10 all over 5 is now equal to K into 30 minus LO all over K 25 minus LO. That is, the left hand side will be divided by the left hand side, while the right hand side will also be divided by the right hand side. Looking at this, we observe that K will cancel. Then we are left with 5 here is 1, 5 here is 2. So we have 2 all over 1 is now equal to 30 minus LO all over 25 minus LO. So from here, we can cross multiply. And if we cross multiply, we'll have 2 into 25 minus LO is now equal to 30 minus LO. And that will give us 50 minus 2LO is equal to 30 minus LO. From here, we can collect like terms. That will give us 50 now minus 30 is equal to minus LO plus 2LO. And that will give us 20 is now equal. When you add these two together, you are going to have LO. So our LO now will now be 20 centimeter. Now, what are we asked to find? We are asked to find, we have gotten our LO. And the question is that we should find what is the length of the spring if the weight is 2 Newton. Very simple question. But before we can get that, we also need to get our force constant. We need to get our force constant. How can we get our force constant? Since we have gotten the initial length, the length of the spring when load is not yet applied. That means we are going to substitute this LO, this value of LO, into any of these two. I can use 1 and I can also use 2. If I should use 1, I will have 5 is equal to k into 25 minus 20. So my 5 now will now be equal to 5k. So divide by 5, divide by 5. 5 we cancel. So our k will now be equal to 1 Newton. Newton per centimeter. Now we have gotten our k, and we can now consider from this equation we said F is equal to k e. They now ask us, the question they ask us is that what is the length of the spring if the weight is 2 Newton? For us to get the length of the spring, now we first need to get E. They gave us weight is 2 Newton is equal to K. K is 1 into E. So we have E. That means our E is equal to 2 centimeter. But remember, I can write, but E is equal to L1 minus LO. E is equal to L1 minus LO. In this case, we are looking for, let's use L3 because we have used both L1 and L2. So we have E is equal to L3 minus LO. So here now we can write E. This one will come here plus LO will now be equal to L3. So therefore, L3 now will now be E, which is 2, plus LO. What is our LO? 20. Adding the two together, we have our L3 now. Will now be equal to 22 centimeters. So therefore, when the load is 2 Newton, length will now be equal to 22 centimeters. We are going to stop here for now. Don't forget to subscribe to my YouTube channel. Don't forget to subscribe to my YouTube channel so that you can have access to all the solving of this particular question. We stop here for now and we'll take it off from here next time. God bless you.